Assalamualaikum. We will present to you about control chart. Okay, what is the control chart? Control chart are used to determine whether a process will produce a product or service with consistent measurable properties. It helps to detect change in the process over a period of time and take corrective action. It is an effective tool which helps to reduce variations in the process and provide information about process capability. Purpose and advantage of control chart. A control chart indicates whether a process is in a control or out of control. It determines process variability and detects unusual variation taking place in a process. It ensures product quality level. It
Type of control chart. Uh, Control chart have two type of chart, which is variable or measurement chart and attribute chart. Variable or measurement chart consists of two type, which is X bar and R bar. Comparison between variable and attribute chart. First, variable chart involve the measurement of the job dimensions, whereas an attribute chart only make differentiate between defective and non-defective item. Variable chart are more detailed and contain more information. Attribute chart is based on go and no-go data require comparatively bigger sample size.
X-bar chart. It shows change in process and it's affected by change in process variability. Secondly, it is a chart for the measure of central tendency. Third, it detects steady progress change like tool wear. And finally, commonly used variable chart. For R-bar chart, it controls general variability of the process and is affected by change in process variability. It is a chart for measure of spread. It is used generally along with X-bar chart. This is an example for chart detail. For this chart detail, we know that the upper control limit or UCL is located at the top of graph. While
Okay, next we want to talk about how to do. First step, we must determine what the type of data you are working with, otherwise quantitative or qualitative. Next step, we determine what type of control chart to use with the data set. And the third step is calculate the average and control limit. This is example for the tabular value. We can see that we have subgroup 1 until 70 and also A for average, D2, D3 and D4. And this is a formula for the X bar. We can use N is the number of observation and X is the number of average. And we have upper control limit and lower control limit formula. And we also have a range that use the maximum subtract with the minimum to get the range. We also have the R bar to get the R bar.
Okay, this is the example of the application control chart used in dimension tolerance. The table is given with the subgroup 8 subgroup and 4 shift. Then we can get the range and the X bar from the data given. Okay, then we can obtain the graph that has a UCL CL and LCL. UCL means upper con, control limit, and CL means control limit. Then lower LCL means lower control limit. Okay, we can get UCL by using is the formula is x double bar plus A2 times R. Then lower control limit LCL we can obtain with the formula x double bar minus A2 times range R. Then CL means control limits. We can plus all the x bar, then divide by 8 because they have 8 machines. Okay, after that, this is a range chart graph. Range chart graph also have a UCL, CL and LCL. UCL, the formula is x double bar plus A2 times R. Then UCL equal to R bar times D4 factor. Then lower control limit LCL formula is R bar times D3 factor. Then CL we can get with all the range summation of all range divide by 8. Okay, that's all. Thank you.